Hi, my name's Calvin. I'm from CARMA, the Center for Computer Research in Music and Acoustics at Stanford. And yeah, today I'll be talking about building smartphone instruments with commodity hardware. And yeah, so I've actually lived here in India on and off since around 2018, except for COVID when I wasn't allowed in. I first came here to work with a nonprofit in Dehradun, and we established a music program and a recording studio there, and it went really well, except there was kind of this glaring issue that many of the women there had disabilities that made it really difficult for them to play a lot of the kind of conventional instruments that had been donated. So in 2022, I received a grant to come back, and I was working with JNU in Delhi to kind of build custom accessible instruments for people with disabilities, focusing on resource-constrained environments and sourcing and manufacturing locally. And this worked really well. You can see there's kind of this hand sensor with a lot of different multi-sensors and capacitive touch, and there was like a musical pillow. And those all worked well, but there was kind of a new problem where all of these interfaces were very kind of customized. There was only one of them. They're kind of Arduino based, and if one wire came out, I wasn't there to fix it. Very delicate. So this lack of scalability really hampers overall kind of collaborative development and pedagogy. And this isn't a problem just for me. It turns out there was a study at the NIME conference about other NIME interfaces that the vast majority of them had only been played maximum of like 3 times ever live. So there's like all these really great instruments and interfaces in the world that are kind of very specialized, very customized, and never really make it out of a white paper. This past summer, I came back with a grant from Stanford to kind of explore how to solve this problem. And the solution that we came up with was to take advantage of what people already have or can realistically obtain, which in this case was Android phones and generic game controllers. And gamepads and other HID controllers easily sync with phones over Bluetooth, and it's easy to develop and distribute for these kind of ubiquitous platforms and adjust them for different use cases. For most of the people I was working with in kind of rural Uttarakhand, and statistically for most people on Earth, mobile phones are like a household's sole computing platform, and among these users, this is overwhelmingly Android phones. So controllers, as you can see here, controllers are really great. As game controllers are really great for music. They're really well engineered, they're very durable, they're replaceable, they're ergonomic, and they have low latency over Bluetooth. And crucially for this, they're available pretty much anywhere on Earth. You can see I've collected these kind of maps of very remote places where you can apparently buy a PS5 controller. And also there's all sorts of kind of generic game controller offerings, which are much cheaper, but have kind of almost the same geometry as the name brand ones, which is important because there's been a lot of great work in the gaming community to develop accessible controller augmentations, which you can 3D print for a variety of different physical limitations and gaming use cases. And these translate really well for creating digital music and art. Sony and Xbox have created their own kind of accessible controller versions. However, they're kind of still pretty niche and hard to find, and they're, I think, $200, like 18,000 rupees or so. And so for our project, I was able to find a 3D printing service in Dehradun. And just looking at Google Maps, you can find a similar service in most tier 2 Indian cities. There's actually one on this road, like a kilometer that way. So it's really easy to do this for people who don't have 3D printers. And you can see here some of the controller augmentations that we had made. Some of them I had made, and some of them, they're kind of these vast repositories of 3D printing repositories where people have posted different augmentations for different disabilities, different use cases, different games. And then people kind of tweak those for kind of even more specialized uses, and you can take them yourselves and modify them further in CAD software. So there's a really interesting one in the bottom right corner where it's an attachment that lets you push all of the buttons on the PS5 controller all from the left hand, and it goes on the table, and then you can move the joysticks, and you have full functionality over the controller all with one hand. So basically, the architecture we came up with was that on the one hand you have, in this case, mostly gamepads, but basically any sort of input source you could have, gamepads, HIDs like trackball mice or keyboards. We didn't use them here, but also you could use the camera, you could use the accelerometer, you can use the touchscreen, anything, any input source from for the smartphone. And then that all goes to kind of an app layer, which does the configuration of, you have all these different import sources, how do you want to scale them, and how do you want to route them to different parts of your audio and your visuals. And then you can have it create JSON presets to save it for different users, different configurations, different styles of music, and then also network functionality, so you can communicate with other phones that are running this over OSC. And then all of this goes to power either the DSP engine and generally at least some sort of GUI, or maybe some more kind of advanced audio visuals, depending on what you want to do with it. So yeah, this was from our deployment this past summer. It was at an NGO just north of Dehradun called CED Society. And the Android app was made with Kotlin, which is like a native Android language, with libpd as the audio engine. libpd is the embedded form of pure data, which you can put into Android and iOS apps. We purchased a generic PlayStation-style gamepad controller for 1,500 rupees nearby, and we hired a local 3D printing service to print a number of accessible controller augmentations for a total of 2,100 rupees. And we used the Android phones that were already owned by the nonprofit center. And so we printed several different augmentations in the form of like grips and the one-handed one. So you can imagine that if you were printing just one, you could do this whole system for around 2,500, 3,000 rupees total. And I was able to configure the app as essentially a Bollywood and Nepali pop remixer, which unfortunately means I can't share the videos from that here because it was all copyrighted songs. But you can imagine that each of the 4 directions on the thumbsticks would be the kind of wet dry for different effects that they could configure and choose. There were like DJ scratching and LFOs and flangers, and then the buttons were mapped to either transport functions or sample triggers. And all of this could be kind of customized, and they could choose their own samples, and they could kind of, depending on their specific disability, we could map it in a way that worked best for them and the way they wanted to play with the song they chose. So now I'll talk just a little bit about some of the audio side of things. So in this project, the audio engine was implemented with libpd, as I mentioned, which is a library to embed pure data into Android and iOS apps. Pure data, as I'm sure many of you know, is a visual programming language. It's basically an open source version of Max MSP. And you have the app side, which is on the right, written in Kotlin. And that does all the routing configuration. And it's kind of like OSC in that it routes it to different addresses that the pure data patch then receives with each of the inlets. So then you can map either bangs or like with button presses or different floats from the the joysticks and other interactive devices on the controller. So you can map those, and you have a drop-down menu where you can select and customize each one of those and then save them as a preset. And you can also, on the bottom right, you can also set it to integrate with other devices over OSC. And then you can have the pure data patch if you want print back into the Kotlin app for visual feedback or for other functionalities, depending on what you want to do. This is really powerful because you can have kind of the app, you can have the configuration, the mapping on one side, and then you can kind of swap in and out the pure data patches. If you want for a different song, a different kind of musical, whatever you're doing, you can have that. It's very modular in that way. There's a few caveats. It's kind of a blessing and a curse that it is very modular, that you can kind of swap in and out these patches in pure data. On the other hand, it's a bit clunky, and you keep having to have things talk back and forth to each other. The other problem is that you can only use the standard vanilla version of pure data, which limits a lot of functionality. And also in my case, where we may want this to be something that I know vibe coding is a controversial subject, but in this case, you might want non-expert users to be able to customize the app and use it as they see fit. So in this case, pure data and all graphical. I did have Claude make a Max MSP patch the other day that worked, which was shocking. But generally, LLMs are not great at making visual programming languages. So that's a bit of a drawback for many people. So another option, at Stanford, we do a lot of work with the audio-focused programming language called Chuck. And actually, I found there was a Chunity, there was someone did a presentation on this at ADC 19. So Chuck is a programming language developed by Professor Go Wang, who is at Karma, and he leads the Chuck development groups. And one of these projects is called Chunity, which is a way to embed Chuck into Unity projects, and then you can export it from Unity cross-platform. And using Chunity, you can combine the really advanced graphics and capabilities of Unity with this now very powerful audio tools. And they're very well integrated. And it works somewhat similar to libpd, where you have the Chuck files on one side and you have the C# files for Unity on the other side, and you kind of have to have them talk back and forth. But then again, that is also kind of valuable, where you can mix and match and have different versions of the audio side or the app side without kind of conflicting with the other. But compared to libpd and Kotlin, there's a much deeper integration in Unity, where you have the game objects and a lot of other things that really bring them together. And the reason I didn't use this, Chunity had kind of become a bit broken in that Android had updated something and then it no longer built for some very small low-level Android reason, but we repaired that a couple months ago, so it's up and running now, and it works really great. The only kind of drawbacks I would say for that are that it's kind of overkill if you just need a simple GUI and a simple configuration menu. It's a bit heavy. It imports all these libraries, and if you're working with underpowered Android phones, this might not be the best option. There's also the Unity licensing to consider if you're working on commercial projects. And yeah, when I had submitted this talk, it was going to end at that. But in the past, very recently, there's been this kind of new development. So first of all, a colleague of mine, Andrew Ade, has been developing a graphics library for Chuck called Chuggle. And with Chuggle, you can build entire 2D and 3D applications that are integrated with Chuck all in one file. And it's really powerful. The only kind of drawback was that there was no way to export this off the laptop. You had to run it from the command line. But very recently, 3 weeks ago, another colleague on the Chuck development team, Ben Huang, has taken this a step further and now ported Chuggle to run in the browser, including on mobile devices and including with game controllers and external HIDs. It's not going to be as integrated or as powerful as a native app or a Unity app, but this really offers a ton of flexibility and scalability in that you can just distribute these kind of audio-visual apps cross-platform just by providing someone with a URL. It's really easy to update. It's free. It's open source. There's also you can find there's a WebChuck and a WebChuggle IDE that's also now built in the browser, and you can sandbox and try out all these things. Yeah, it's still really new. It should be released on GitHub quite soon, but I think you can still try it out. The documentation is up, I believe. But it really just opens a lot of doors in terms of be able to just hand someone a URL and they have a whole audiovisual app. To demonstrate this, here's kind of a 3D version of iTabla Pro I made. So it's pretty basic. You can just mainly just looking at like the visuals, but you can go around and you can select the different complexities of each of the beats, and then you can see if, what happened. It's a really powerful 3D environment, especially to just be running on a browser app. And yeah, so in conclusion, more than likely, most of you will not have the same use case where you'll be wanting to develop these kind of accessible instruments for remote communities. But whether you're working in industry or research or the arts, this kind of modular framework and taking advantage of what people have and having this kind of mix and match capability where people can configure different parts of it to suit their needs is really powerful, and it's a great way to make shareable and adaptable mobile-based instruments for a variety of use cases. And as I mentioned, the world is full of amazing custom digital instruments. I've made a few, and that just never evolve or kind of have more than one user because they're these unique one-of-a-type prototypes to leverage commodity hardware in this way, like smartphones and game controllers, along with the sort of modular customizable software, allows for instruments that are really accessible, affordable, and have a much higher chance of widespread adoption. And I might have too many QR codes, so I'm sorry. I realize it might be hard to scan all these, but please talk to me after if you have any questions about this. Thank you.